Hello everybody, today I'm going to show you how to change multiple angles to powers. Over our few previous lessons, we've been dealing with expressing powers of sine and cos into multiple angles. Today we're going to deal with changing from multiple angles into powers. Okay, now we know that if you have a complex number z raised to power n, this is identical to cos theta plus j sine theta, assuming that our modulus is 1 raised to power n. Okay, now this is the polar form of this complex number, so applying De Moivre's theorem, we get cos n theta plus j sine n theta. Okay, now if you are told express sine 3 theta and cos 3 theta in powers, now what you need to do is that since we want sine 3 theta, the only way we are getting sine 3 theta, we could write it like this. This can be written as cos theta plus j sine theta, which should be identical to cos theta plus j sine theta. Okay, so we can apply, in order for us to get cos 3 theta and sine 3 theta, we can apply De Moivre's theorem on the left hand side. Okay, so we get cos 3 theta plus j sine 3 theta. On the right hand side we leave it at like that, plus j sine 3. So on the left hand side we have applied De Moivre's theorem. On this right hand side, I want us to expand this. Okay, and then compare the real and the imaginary parts. Okay, so that we don't have quite a long expression, let's say let cos theta be equal to c and j sine theta be equal to j s. Okay, so that we don't have quite a lengthy expression. Okay, let's proceed. If that's the case, we will have c plus js raised to power 3. Okay, we want to expand it, so using Pascal's triangle we can get the coefficients. So this should be 1 1 1 1 2 1 1 3 3 1. Okay, so let's expand this. So this will be c is for 3 plus 3c per 2 js. Okay, plus 3c plus js raised to power 2, and finally we have js raised to power 3. Okay, so let's simplify it. This will reduce to c power 3 plus this is 3c squared j s plus 3c j squared. J squared is negative minus 1. Okay, j squared is minus 1. J squared is minus 1, so this is s squared. Sine squared is sine squared, and plus j cubed is minus j sine cubed. Okay, so we have, what we now have is that cos c cubed plus 3 squared js minus 3c s squared minus j s cubed. Okay, now let's separate the real and imaginary parts. So we have c cubed, this is real, minus 3c s squared, this is the real part, plus the imaginary part. We have, this is imaginary, this will be 3c squared s minus s cubed, and we factor out the j. So this is the real part and this is the imaginary part. Okay, now don't forget our initial expression was this one, cos 3 theta plus j sine 3 theta is equal to this, and we have expanded the right hand side, and this is the result. So now we want to compare the real and the imaginary part. Okay, the real part of this equation is cos 3 theta, and it should be identical to this right hand side. Okay, c cubed minus 3c s squared. Now that's this is the real part. So this can be written as cos 3 theta minus 3 cos theta. Instead of writing sine squared, I want to change it into cosine, because I want to change it into cosine. So if I want to change it into cosine, it will be sine squared is the same as 1 minus cos squared theta, using this trigonometric identity. Sine squared theta plus cos squared theta plus sine squared theta should be equal to 1. So making sine squared theta the subject, you get this. Okay, thereby I'm writing everything in terms of cosine. Okay, so what we have finally is that cos 3 theta is equal to cos cubed theta minus 3 cos theta, open the bracket, plus 3 cos cubed theta. Okay, now we have written cos 3 theta in powers of cos. Okay, we have converted it from multiple angle into powers of cos theta. Okay, that's that. Now for the imaginary part, the imaginary part is this one. This is the imaginary part, and the imaginary part on this other side is j sine 3 theta. Okay, so we compare those two sides. This will be sine 3 theta should be identical to 3 cos squared s minus cubed. Okay, that's that. Now we want to write everything. Everything in terms of sine. By doing that, we have to change this cos squared using this identity. Now we want to write everything in terms of sine. Okay, so we have to change this cos squared using this trigonometric identity. Okay, so it will be 3 into bracket 1 minus squared. Okay, minus s cubed. So if you open this bracket, we will have 3 sine theta minus 3 sine theta minus 3 sine cubed theta. Okay, minus sine cubed theta. Okay, now we have written everything. In terms of powers of sine. So that means that sine 3 theta is equal to that. We have converted sine 3 theta into its powers of sine, So that's how it's done. If you are told to convert multiple angles of sine and cosine, that's how you go about it. You just using De Moivre's theorem, apply De Moivre's theorem on the left hand side and expand the right hand side. Okay, then you compare the real and imaginary parts and you get your answer. Okay, thank you for staying with me. This is Understanding Math.